We are discussing programming for linked list. There are few operations and how to define a linked list structures we have already studied. Hope you are practicing all the programs that we have discussed. So, today we will cover few more operations related to the linked list structures. So, today's operations include deletion at different situations like deletion at front, deletion at end and deletion at any position. We have discussed one usual traversal operation, namely printing a list. Today we will discuss another operations related to traversals, namely how a list can be reversed in the order of the data that is appear during the input. And finally, we will conclude today's lecture giving idea about how to program for the linked list, double linked list structures. Now, let us come to the linked list structure again. So, we will discuss about how the other few methods related to deletion can be covered here. So, today's methods related to deletions, there are three different methods regarding the three different cases. Like deletion at front, we declare this method as delete front. This method does not require any argument, but it will return the value of the node that it has deleted successfully. Then deletion at end, it also does not require any arguments to be passed to this method. It will return the value of the node that it deletes successfully. And finally, we will discuss about delete at any position given a key as an argument, that means which elements you want to delete, as it does not require to pass any value, return any value. So, it return type is void. So, these are the three methods related to deletion operation will be covered. Now, let us discuss all three methods one by one. First, we shall start with delete front operation, that means deleting a node from the front of a linked list. Now, there are two cases possible in this operation, mainly deleting something from an empty list. Obviously, there is nothing to delete. So, in that case also, if you call the method for a linked list, then it will not return anything, rather it will return null. And the second case, the linked list is non-empty. In that case, the deletion will be simply manipulating the links. So, first we have to go to the first node, let the first node be temp. Then once you know the first node, from the first node we know the link field, link of this node, that means this basically links the next node. So, what we do is that we will just assign the pointer of this header dot link by the temp dot link. So, this basically will set this one, and finally, we will mark this link field as null, and by this process this is also this no more exist, and then we can return this node to the memory bank. So, this is the procedure for the deletion at front is concerned. Now, let us see how the method for this link manipulation can be defined. So, we are to add one more method in our linked list structure that we are defining. We have already added many more methods: delete, insert at front, insert end, insert key, like this one. So, this is another one member needs to be added. this member is delete frond. Now, let us see the body of this method. This is basically the code. This code includes what are the links needs to be manipulated. Here, as I told you, we have to start with the first node of this link, and now see this is valid even the list is empty. So, whatever is the situation that we have discussed, whether the list is empty or not empty, all these operations are valid. So, two situations, two cases may be empty or non-empty, but all these link manipulation is common. It is written in that way actually. Now, here if temp not equals to null, then only we will do. If temp equals to null, return x, x is initially null as I told you. So, for empty list it will return nothing, null rather. Now, here you just see what pointer manipulation we did it. First we store the value of the temp node which has to be deleted. So, temp dot data equals to x, and then we just change the pointer of the header link by the pointer that the temp node points to its next node, and then we will just print that the element has been deleted successfully, and finally we return the value that has been deleted. So, this is the method so far delete frond is concerned. I hope it is you able to understand it. And so, this is the first method. Now, let us consider the another method delete end. Now, delete end method again there are two situations, empty list or non-empty list. In case of list is empty, we do not have to do anything. In that case, if we call this method for a linked list, it will return null. On the other hand, if the list is not empty, then what we have to do, starting from the header, we have to go to the last node. Let the last node be temp. This is the temp is the last node. While we are visiting starting from the header to the last node, each moment we should keep a track of its previous node. That means the node just one node ahead of the current node. So, this is the previous node. Now, this node is required. This is because the deletion will take place only by assigning null value to this one, and that is enough. So, this basically deletes the last node. Now, this become free. So, we should return this node to the memory bank. So, this is the operation delete at end. Now, let us see the code for this method, this operation. We have to add one more method. The method is delete end, and the body of the method is here, which includes the necessary statements that is required. So, here t is a temporary, x is a temporary, initially it is null, and this basically starting from the header node. Now, if t is equals to null, it will take care about the empty list. If it is not null, then it will do these things. Now, here if it is not null, then this while loop basically moves from the current node, that is the header node, to the last node. So, this is the usual what is called the movement operation that you should do, and you can check that we are maintaining two pointer previous and temp. Previous is basically one node ahead of the currently traversing node, and then when we come at the end, so we copy the value of the temp node into x, and we make the null pointer of the previous node as a null, I mean link fit of the previous node as null, and that is all. So, this is the method that we can follow in order to delete a node from end. Now, our last operation, this is delete from any position. That position will be dictated by the value of the node, which basically passed as an argument to this method. So, let key be the value. We want to delete a node having this value key. Now again there are three situations may have. One situation is that list is empty, then other situations is list is not empty, but key is not present in the list, and then the third situation is that list is not empty and key is present. Now in the first two situations, whether list is empty or list is not empty but key is not present, in that case we do not have to delete anything and that is all. Wherever if the list is not empty and key is present in the list, then what we have to do, starting from the header, we have to traverse and reach to the node where the key value presents. So, let temp is the node where it contains the key value key, and while we are traversing to the target node, we have to keep a track of the previous node all the time. So, when we reach it to this node, so let previous be the previous node. Now, once we reach to the target node, our link manipulation is like this. We have to assign this previous dot link field by the address of the node, which basically points by the temp, that means temp dot link. So, previous dot link is equals to temp dot link, and it will make this kind of pointing. Then we will do this null, and finally this is already done. Okay. So, this node is then free, and we have to return this free node into the memory bank. So, this is the link manipulation that is required. Now, let us come to the method declaration. So, method declaration is there here, like the other two methods for deletion. We have to add one more method, delete key here. In this case, the method includes these statements. The statements are like this. We have to start with the header node, and here if you see, while temp not equals to null, if temp not equals to null, we have to come to end. We do not have to do the temp is null, means we do not have any node there, list is empty. Now, if list is not empty, then while loop we will enter into the while loop, and here we have to, in this while loop again we have to go to the target node. So, there is while loop, that temp, here we will see, we will just move one by one. Here is a movement, we will continue this movement until temp dot data equals to key. We do not write this is the target node actually. So, we reach to, so if we continue this, we will ultimately, if the element presents there, we will be able to reach to the target node. If we do not find at the end node, we will not do anything. So, while loop will continue till, and then if we reach to the null, then we will not do anything. But if we find that key is present there, then we will just simply element is deleted. So, this deletion will take place like this. This is the two link manipulation as you see it here, and this way it will continue the deletion. So, this is the case that you can follow. So, for deleting a node from the list which is which contains the element and it is also not empty. Okay, so, we have discussed three different methods related to deletion operation, and here is the one driver method, the master program, which basically check or to test how the operations works. Now, here let us see, again we have to create a linked list. Let the name of the list be list, and we just insert few nodes into the list. Here we insert 1 to 8 numbers. After the list is loaded, then we print the list, and then subsequently we follow certain deletion operations. Here delete key, that means it will delete this node, then delete front, delete end. You can call many other delete method here also. So, this way you can see at each point it will do the deletion operation, and then it will, in this case suppose you can call delete key 12. So, in that case also you will see, because key is not present here, but it will not delete anything because nothing to delete in that case likewise. So, you can test this program and then see whatever the method that you have defined, it works for you. So, this is the deletion operations. Now, we shall learn about reversing a list. Now, list reversing is pretty simple actually, but we have to be little bit understand about how actually the reversion operation occurs here. Now, suppose this is the linked list and this linked list contains few data, say this list contains A, this node contains B, C, D and E. Suppose this is the list that is given to you and this is the header. This is the header. Now, we have to reverse. Reversing means that this list will contains this node will E, then D, then C, then B and A. That means it is in the reverse order, whatever the order it is given there in the reverse order. Now, we can carry out this reversion operation. I am just going to explain you how the mechanism of reversing. There are many techniques are known, but we will discuss one simple most technique that is easy to understand. So, the idea is basically the principle behind this technique is that delete the last node, that means end, and insert the same node at front. If you do it, then your reversing operation is done, and then this method we have to repeat, delete at end and then the same node should be insert at front. We have to repeat till all nodes are basically go through this operation. Now, how it can be done? So, initially we are here and then we can come to the first node. So, this basically let this be the current node, and then starting from this current node we will go to the last node. So, this is the last node. Now, so we know this last node and then we shall delete this node. So, delete A, but this delete means we will just make a copy of this node actually, and then that means copy of this means the value of the node E is copied. So, then let the value of the E is there. Then what we should do is that the current node which is here, just before this current node we have to insert this node. So, this node will be, so here, so this node we can get a node and we can make a copy of this node E, and then we can just insert at this point and this one, and then this basically delete. Okay, fine. So, this is done. Again we have to repeat the same thing again starting from this current node, and then next is the last node is D. So, we have to delete again this one. So, in that case again delete this last node and insert at the front. So, our next time, so this will be here, sorry, we should delete just before to the current node. So, this node will be deleted here. So, it is like this. So, D, and then we have to insert this D node just prior to this node. So, we can make into this pointer, and then this pointer we have to make to this one. So, this way you can see this is basically deleted and this is become deleted, and if we continue this one, then C will be added here. So, this will be there and it will be there, and then finally B, so it will be there A and here, and when there is no more the last node, like we can stop. So, when we reach here, so there is no more node to be deleted at the end, so we can stop, and this way we will be able to reverse it. So, this is basically the mechanism, and you can follow the mechanism actually again. And let us see the code for this. I made a code for you, you can check this code and then you will be able to understand that how this code works for you. And so, the reverse method operation regarding reversal, and here is the code that is basically there, and this code is basically to go to the last node and delete that last node and then make a copy this last node just before the current node. So, this method does there, and we have to just call this method starting from the car node. This is basically the main operation of the reverse, and this is basically sub operations actually. So, that this reverse call this remove node, this remove node is defined here, and this will work for you. You can check this one, and also you can find many other method which is available in many textbooks, you can follow also, and you can try to implement regarding the reversal one. Many books they recommend to perform this reverse operation using some recursive method, that also interesting to note. I mean, you can study it and you can implement using the standard procedure that I have discussed in this class. So, this is the operations related to the single link nodes. Now, again utilizing the different methods related to insertion, deletion and then reversal. Here is another master program that you can call different methods for a given list. So, you can prepare a list using these procedures, it is mentioned there. Here only we have exercised the reverse method, the node that is being those are being inserted into the list. Now, if you call this reverse method, you will see they will reverse the ordering of the nodes. So, these are the different methods related to the linked list, programming linked list, single linked list rather. We have learned about it, and it is just matter of practice. If you practice all programs one by one, adding one method each time and then testing the program, writing a master program, you will be able to understand, and I should suggest you to practice it seriously. Now, let us come to the double linked list. Double linked list programming is same as single linked list. We have to first define a structure. In case of single linked list, we have defined structure with only one link, but in case of double linked list, we have to define two links in addition to the data. So, just one more link. So, you can replicate the program by modifying something which is required for double linked list. So, you can define a node in case of double linked list, and then linked list structure same as there also a header, here is also a header, but header again the header, the left link of the header should be made null, like that point, that consideration you should have, and then come to the different operations. All operations if you follow one by one, then you have to see the link manipulation is not exactly same as the single linked list, because for the single linked list only one link that needs to be manipulated, whereas for the double linked list we have to manipulate two links for each node, those are coming into the picture. So, the link manipulation which we have discussed for the single during the discussion of this data structure and then algorithm that you should follow, and I left is as an exercise for you, so that you can practice of your own and then you can follow. Otherwise, if you can follow the books here, the algorithms are there, that algorithm also you can follow. This algorithm is given in a pseudo code format, and you can follow this algorithm to implement all the operations related to the double linked list. And related to the application also in this book, you can we have discussed many applications there. You can follow the different applications and then you can implement all those applications just writing the program. and for each program implementation or application related, you do not have to define the same declarations again and again. What is the idea is that you can maintain a package where your defined linked list structures and all methods in it can be there, and you can import this package into your application program and then just simply call the different methods whenever it is required. For example, if you want to insert at end or delete from front, whatever it is there, you just call this method and it will work for you. So, regarding this application or writing a master program related to a particular application, it is left as an exercise for you, and all the programs which we have followed in these lectures and in previous lectures related to linked list programming is available in this link. So, and then in this link also include the detailed discussion about whatever the topics that we have discussed in these videos and in last few videos related to linked list structures. So, you can check this link, you can get all the reference material there, and then program including you can practice it. So, this is about the programming for linked list second part, and okay, that is fine. More practice, that will help to improve your skill. So, that is okay, fine. I wish you all the best for programming endeavor. Thank you very much.